Increasing order of acid strength among para-methoxyphenol, para-methylphenol and para-nitrophenol. Let us write the structures of these three compounds. Para-methoxyphenol, para-methylphenol and para-nitrophenol. Okay, phenol dissociates to give phenoxide ion and H plus ion. Phenol dissociates to give phenoxide ion and H plus ion. If phenoxide ion is stable, then phenol will be more acidic. If the phenoxide ion is more stable, phenol will be more acidic. Now suppose there is electron releasing group on the benzene ring. If there is electron releasing group on the benzene ring. For any charged species, the stability depends on the charge intensity. If charge intensity is more, stability will be less. If the stability of phenoxide ion is less, acidity of phenol also will be less. So what happens if electron releasing group is there on the benzene ring? The negative charge intensity on oxygen increases. If the negative charge intensity on oxygen increases, stability decreases. If stability of phenoxide ion decreases, acidic character of phenol also decreases. So electron releasing group on benzene ring decrease the acidity of phenol. Whereas if there is electron releasing group on the benzene ring, if electron withdrawing group is there on the benzene ring, if there is electron withdrawing group is there on the benzene, what happens? The negative charge intensity on oxygen decreases, because the electron withdrawing group will withdraw the electrons towards itself and decrease the negative charge intensity. So if negative charge intensity decreases, what happens? Stability increases. If stability increases, acidity of phenol also increases. So electron withdrawing group on benzene ring increases the acidity of phenol. Now let us see. NO2 is a strong electron withdrawing group. OCH3 is electron releasing group. CH3 is also electron releasing group. NO2 releases because of resonance effect, minus effect. NO2 withdraws electrons because of resonance effect. OCH3 releases because of resonance effect, but CH3 releases because of hyperconjugation. CH3 releases because of resonance, CH3 releases because of hyperconjugation. But resonance effect predominates over hyperconjugation. So OCH3 destabilizes phenoxide ion more compared to CH3. So what is the order of acidic character now? Acidic character is directly proportional to the stability of phenoxide ion. So para-methoxyphenol is less acidic than para-methylphenol, which is less acidic than para-nitrophenol. This is the order. Para-methoxyphenol is less acidic than para-methylphenol, which is less acidic than para-nitrophenol. So what is your answer there? Para-methoxyphenol less than para-methyl less than para-nitro. So your answer should be option D.